welcome to project number 2. So in this project, we're going to be looking at brain tumor classifications using machine learning. So before this project starts, I just want to state that my RAM is off the charts, literally, and I wasn't able to fully compile this code, but this code fully works because I had compiled it in different sections and different kind of IDEs and whatnot. But this is the altogether version. So first things first, we want to import a bunch of stuff here. And also I'm going to be going through this relatively quickly because I have an exam to study for tomorrow. So we have to import lots of libraries and whatnot. And then this is us fetching the data set from a website from Kaggle right here. So we can see our source right here. And we have a zip file, so we unzip it. And then this is our data right here, and we create a data frame with this, right? So with this data frame, we have the training data frame and we have the testing data frame. And our data is actually very balanced, I would say, right? As we can see here, compared to the last project, it was not as balanced. So our data set is very balanced. So more imports and more visualization of the data frame. And then right here is where things get interesting. So the validation data and testing data are evenly split-ish, as I said, right? And then we just want to use like generators to create 3 data flows, one for validation, one for training, and one for testing. So right here we have the validated images and whatnot. And then we just want to look at our images to see if they actually have, the proper headings, the proper classification, and then we will train our model to recognize these non-tumor. And we have different types of tumor right here. We can see them. Actually, no, this is just the stem, I'm pretty sure. I don't know. I'm not a neurosurgeon, unfortunately. But we can see different types of tumors, brains that, maybe the images and maybe writing over it. So obviously these are going to be like discrepancies towards our model, but we are going to do our best to make sure that our model gets it accurately. So we're resizing the shape right here just so that every single shape is evenly spread out so it doesn't confuse it, right? And then in this case, we're going to be using this model, exception model right here. So I actually ran this previously and I got about a 99.06. As I had previously mentioned, I did get a 99 point right here. I don't know if you guys can see this image, but it is 99.98. If I'm 99.9, well, 99.69%. So that was the accuracy for this model right here. But unfortunately, it's not running right now. And like I said, off the charts. So continuing, we are just getting the training and validation metrics from history. And then we're just, obviously, it's supposed to have a graph right here. And you can see that there's actually a space for the graph. But unfortunately, we cannot see the graph. I will be providing examples a little bit later of, what it should look like. But we just have predictions here, and these are supposed to be like 100 or 1, right? And once again, changing the batch size because we're actually going to train with another model, which is a CNN model. And we are doing this because, well, obviously the CNN is less memory, and in a real world situation, it would be less expensive. But we're doing CNN just to explore what could be in the variances that exist between these models. So same thing as the previous one, and predictions and whatnot. Now now we want to make the website, right, or the web app. So we're gonna have install Streamlit and Pygrok. Yeah, there you go, my fault. And we're just gonna go right through it. So this is gonna be our app.py, and this is going to be where we will have our code, or not our code, but our web app. And I'm just not gonna open this right now because my API key is in there, and I don't want to leak that because it would be very bad for me. So right here we are doing prompts, right? And we're getting open AI, right, or GPT, if you will, to Gen AI, you know, to answer these prompts. So we're gonna feed it the information that it requires, and then we're just gonna get the result back or the answer back in a human way or human explanation, one that humans can read, which is what I mean. So these are just resizing the gradients, and this is just making, once again, the website look pretty and all, with different columns, with different titles, with writing on it, just so it looks pleasable, right? And then once again, plotting charts and whatnot. And then at the end here, which is very important, right? We create our own URL, and this is once again the API key that I will not be leaking. And these are just tunnels that we're creating, and I don't understand why I have the same one twice, but I was trying to maybe play with it or something like that. And yeah, that concludes the brain tumor classification. Now I will be providing examples because unfortunately, my RAM is going a little bit crazy now. After I've posted this to the GitHub, and if you haven't followed me to the GitHub on the GitHub, I strongly recommend you do that at 1Tony0. But after I've posted this, we can see the outputs, right? And we had these graphs, we had everything here, which is very good, very good. But where we started lacking was right around here, right? And these are just going to be the different epochs. And this is just like every time that it ran through it, we can see that the accuracy increases as it progresses and as it runs. Unfortunately, this one did not increase, but I'm sure that if we had another one, it could possibly increase. So we could play around with those values and just see. So we're just gonna make graphs for us to see easier, these values. And once again, these are the things that did not load while I was doing it on the previous one on the Google Colab, right? And then we make a confusion matrix. And if you're confused about a confusion matrix, so am I. But it's just a representation of predicted and true labels for our data frame. Or not our data frame, but our machine learning predictions. So now we're going to have to split these up into different sections, right? And the way that the machine analyzes this section by section, right? And then it makes a prediction based on the content that it sees. So obviously here the prediction is very high, right? Or the probability is very high. Probability is very high, and probability is very high, which implies, well, the probability is very high on a chance that there is no tumor. Or, sorry, no tumor, but not a no tumor, but a specific type of tumor. So this implies that truly our model is learning, our model is correct, right? And now we can put it to work. So we're putting it to work, and then we're actually going to try another model, right, which is the CNN. And we're going to compare how those values for the CNN differ from the original model. So right here we create a CNN model and we give it the same type of starting conditions and whatnot, and we're going to compare, and you can just compare it, where is it, right here, right? We can see that the accuracy is 88, whereas the other one was close or above 90. So we can see the difference, right, between them, but it's just so, for learning purposes and whatnot. So we make these into graphs once more, and then once again, just looking at the test scores, make another confusion matrix. And now we get more into the application, the web app part of it, which I won't be going through as much because I will be showing you the website itself. But once again, everything here is mostly just to make the website look good and organized. So hopping onto the website itself, right, we can see that we have everything all good, all set, ready to go. Here I chose the second one right here. And what happens is we're using the exemption model right now. And we can see that it's trying to detect something here, but unfortunately can't pinpoint something specific, which it results in a no tumor, and it's 100% sure that it's a no tumor. So then it explains it. Wow, a score of 99.999. I'm not going to read all those numbers. So we can try a different model perhaps, and obviously this one, to the human naked eye, we can clearly see that there is a model, or that there is a defect or a tumor, if you will. And you can see the model does pick it up, and it does pinpoint that one specific spot, and it will give you the precise brain tumor, and it gives a detailed explanation. So we can try with one more, perhaps this one right here. I do think that there is a tumor here. Yeah, and there is a tumor. Like I said, I'm no neurosurgeon, but the way that this model operates, it might as well be one. So that brings a conclusion to this brain tumor project. It was very fun making it, lots of challenges, lots of lessons, and I definitely recommend someone to do this. The code can be found on my GitHub, and you can just fork it, make maybe some changes to the machine learning model, try to make it more accurate, and just play around with it and have fun. Thank you for watching, and I'll see you on the next project.